Hi, I welcome you motor control for EV application section. So in this topic, we will discuss about what is motor, what are the parameters of the motor, how we can control the motor. So everything we will discuss in detail. So keep engaged with this entire session. In electric vehicle applications, the motor is mounted either in the front wheel guidance or back wheel guidance drive. Generally, the motor in this latest electric vehicle applications comes up with a complete integrated drive system. So if you can easily understand from this image, the motor is mounted with the power transmission system, and if you apply the control signal to this motor, then we can effectively drive our vehicle systems. And what is a motor? See, generally the electric motor will receive electrical energy from the source, and then it will process it inside the motor. So generally it will be a magnetic field, and finally it will convert electrical energy to mechanical energy. So now we are going to use this mechanical energy to drive our electric vehicle systems. So this is the basic concept of the electric motor, and the working principle may differ based on the motor, various types of motors. So let us check for what all the motors are available in the market. So before discuss about the types of motor, you should know what is your expectation from the motor. So the first factor is that higher efficiency. So always you should expect from the motor is about high efficiency, high instant power, and fast torque responses. And similarly, that high power density and low cost. That is again the low cost for the production aspect, and acceleration, high acceleration, and robustness. So these are all the important factors which is expecting from the motor. So if you're going to design any electric vehicle, then you should keep these points in your mind to choose your electric motors. And see here again some of the factors as mentioned, like a torque, speed, and power, so and cost. So let us check what is a motor torque and what is a power, and then what is a speed. So everything we can easily understand from this session. So keep engaged with this session, don't skip this topic. And see, if you take a motor performance, see here, if you draw a curve between the torque and that speed, so there are the two kind of section. One is called below critical speed, and then above critical speed. So the below critical speed, the critical speed nothing but that is the rated speed. So if you drive your system within that range, then you will get a constant torque. Similarly, if you drive your vehicle on the above the critical speed, you can get the constant power region. So in that region, both the parameter like a speed of the vehicle and the torque of the vehicle may change. So the point is, your control system should identify the maximum torque at a given speed range. So again, you can drive your vehicle at any point of from this graph, but subsequently you should sacrifice any one of the behavior. If you want to pull your heavy load with your vehicle, then you should always operate your vehicle under that below the critical speed. So you may experience that the fully loaded truck may travel while it crosses the bridges. So definitely the truck speed will be very less comparatively normal speed. So during that time, so we are allowing the vehicle to run our motor in the constant torque region. So in that case, during this period only we can drive our we can drive the maximum load. So like that we can understand the concepts of torque and then power region. And so what is the type of electric motors? The type of electric motors, generally we can classify it into two types. So one is the commutator motor and then commutator-less motor. In the commutator motor, so again there are two types. One is called the self-excited and then separately excited. And so in the self-excited, there is a series motor and then shunt motor. Similarly, in the separately excited, field excited, and then permanent magnet or compound motor. And in the case of commutator-less motor, the first one is the synchronous motor and asynchronous motor, and similarly the PM permanent magnet brushless DC motor and switched reluctance motor, and then permanent magnet hybrid motors. And here synchronous motor again divided into three types. One is called wound rotor motor, and then permanent magnet synchronous motor, and the switched reluctance motor. And so again here there's asynchronous motor called induction motor. See, again in this induction motor, wound rotor motor and then squirrel cage motor. So these are some some classifications of the electric motors. So each and every motor has its own behaviors. That is a torque, speed characteristics, power and versus speed characteristics, and full load and then efficiency. So everything is there. So based on your applications, where you are going to use that one, and then specifications of the applications, then you can choose the motors. See, again in all the from this motors you can use a DC motor for your electric vehicle application, that is a permanent magnet DC motor, and then BLDC motor, switched reluctance motor, and then hybrid motors, induction motor. A wound rotor not possible to use in the applications, whereas a squirrel cage you can use it. Similarly, in the synchronous motor, like a PMSM can be used, and then synchronous reluctance motor can be used, reluctance motor can be used. But while you choose the motor, so you have to identify the vehicle specifications at desired cost range. And similarly, this is the notes you can download, you can use it for your future reference. And similarly, what is the commutator motor, and then what is the commutator-less motor? See, the commutator motor nothing but the electrical power supply can be transferred to the motor via some commutator. So this is the commutator part. So this is the commutator part. So this is the commutator part, and inside that commutator there will be a brushes. So it will give you the exact physical connection. So with this connection only we can transfer the power to the motor. So whenever the power transferred to the motor, then only the magnetic field will get energized. So whenever you receive a magnetic field, then we will operate the motor. So like this we can classify it as a commutator and then commutator-less. So under that commutator-less we can classify all the kind of motors. See, here in the commutator-less motor, again the same concept only we are going to use it, but there will be instead of the physical commutator, we are going to use some of electronic commutations. So the motor along with the electronic circuits. So this is the commutator-less motors. And other motor types called the synchronous electric motor is that the rotor speed will be equal to this supply frequency, that is called the synchronous motor. And asynchronous motor nothing but induction motor. Actually the rotor speed will not equal to the supply speed. In that case the slip will be there. So because the rotor the stator magnetic field will intersect the rotor. Whenever it intersects, then the rotor will try to receive a force to rotate from its standstill position. Each and every motor working principle, constructions, and then speed control mechanism, everything we will discuss in this forthcoming sessions. And so what are all the basic motor parameters? So the first one is motor power and motor torque and then motor speed. These parameters can be easily understood with this animated video. If you take this video, you can easily understand these parameters from this animated video. So I will play you an animated video. So please keep. See, if you take a motor, see actually in this shaft is a deliverable component. So whenever you apply the voltage or power to the motor, then the shaft will try to rotate it. So the rotate nothing but the shaft should reach the 360 degree. So in that case, whenever the shaft reaches to the maximum or the entire degree on that with respect to time, that is called minute or second. If you cover the within a minute, then it's called revolution per minute. And the torque is nothing but the force acting on the shaft to drive the load to cover the distance. That is that let us consider that one free feet. Actually, that in the animated video generally it's mentioned that pound per feet. So in that case we can that is the torque. And the power of the motor is actually in the ancient days they have measured the work done by the horse. So that is called power with the help of the basic data, with the help of basic value. So that is measured with the help of, that is pound, and then pound feet per minute. So earlier again they have converted to the SI units called 746 watts. Suppose if the horse finished finished its work with this power, it's called 1 HP. Like this we can easily understand what is the ratio between the power, speed and torque in this electric vehicle system. So how we are mounting the motor? See, from this image you can easily understand that single motor is used to drive this two wheel, and again that this two wheel only going to guide the entire vehicle systems. Similarly, again few more driving system is there. It's called dual drive. So there will be either a single motor or dual shaft motor can be used to drive this entire transmission systems. And similarly that all wheel drive system. So race cars have a all wheel, that is complete wheel drive systems. So like this we can easily understand the concept of the drive wheel systems. And still nowadays the entire wheel comes up with the integrated motor and then controller. If you take types of motors available in the market, see here, this is the hub motors used for the two-wheeler systems. And similarly this is the motor for the this is called axial motors used to drive the electric vehicle system. Then this motor needs a separate transmission systems to connect your vehicles. And so like this we have to take connections. So this is the motor and then mounted with the transmission systems. And similarly this is the two-wheeler motor. So this two-wheeler motor will have a connection between the motor and wheel with the help of the gearing mechanisms or speed reducer or increaser mechanisms. And here this is the dual shaft motor. So the shaft will be terminated again both the side of the wheel. So like this we can connect the motor to the electric vehicle systems. And now what is the motor control purpose? How the motor control mechanism is invented to achieve some specific reasons. So in that case, to start the motor, similarly to stop the motor. So straight away we cannot, whenever you connect a motor to the supply, then the motor should not run on any drastically. So in that case we should provide a unit to start and then stop. Similarly that reverse mechanisms, and to run at a specified speed range. Similarly that speed control. Suppose if you want to drive, if you want to change the speed while it is in the running conditions, then your controller should deliver on particular speed. Similarly the safety of operator. So while you change this speed, then inside the motor should not any issues rise. Similarly protection from the damage. And generally in the electric motors, inside the coil winding, so the important factor will be placed called insulators. So while in the operating conditions the temperature may rise, so due to the temperature rise the insulation may get break. So that is again that insulation breaking may appear. So we have to constantly we have to monitor the rotor or stator current. From the current behavior we can identify the insulation strength. So it's being, I mean, in the electric vehicle it's being a critical parameters to identify the motor health also. So in that aspect your drive should support to protect the motor from the faults. And what are the types of motors controllers? See, this is motor starters. So this starter is used to start your vehicle, start your motor from the 0 speed to maximum speed. And similarly, reduced voltage starters, nothing but dual dual starter has been used to change the voltage from 0 to maximum. So generally it will be like this. So the solid state starter is used to get a reduced voltage starters. And similarly, that adjustable speed drives. The adjustable speed drives nothing but it's like a VFD, again basic VFD. And next one is that intelligent controllers. So here the intelligent controllers nothing but the microcontroller will monitor the user command as well as the motor command, and it will take a controlling action to generate a pulse width modulation to drive the motor. So all the things will be integrated and to run at a specified range and then specified load conditions. And similarly, that servo controllers, the servo controllers is used to drive the motor at a specific position. If you want to drive the motor with the exact position, then the servo controllers can be used. So like this, these are the some different type of motors. So in this forthcoming sessions, we will discuss in detail what it is and how we can achieve the motor control mechanisms for all the motors, like a DC motor, induction motor, and PMBL DC motor, PMSM motor, and SRM motor. So the 5 motors can be achieved with this type of motors controls. And so let us check 10 factors to choose the motors for EV applications. How we can choose the motors? So these are the motors, these are the factors to choose the motors. So first one is the electric vehicle characteristics or dynamics. And second thing, drive cycles. The drive cycle is nothing but, so again this driving cycle can be vary based on your locations. So suppose if you take around the world about 7 continents, so each and every continent the drive cycles may differ. Depends the road conditions, depends the climate conditions, depends the other factors. And second one, that is the vehicle configurations. The vehicle configuration nothing but whether it is in the electric or hybrid. So how the vehicle in the vehicle motor is configured, like again single axle or dual axle or multi axle, and series, hybrid. So like that, parallel, like that we have to choose the configurations. And next parameter is the speed of the vehicle. So what is the maximum speed, and similarly maximum torque, how much load can be achieved. And the torque, when you taking up the take the parameter of the torque, then you should consider the hill climbing factor. So at what grade you are allowing, like a 45 degree or 20 degree or 10 degree. So what is its maximum range? And similarly the maximum power, and then battery capacity, like a single charge or range distance to cover it. Similarly the battery terminal voltage. See here, the battery terminal voltage, if you keep a lesser voltage, then the current will be high. Similarly in that case, the current handling inside the motor is, again it's a typical very typical parameter. So in that case you should provide the conductor size and then insulations, everything you have to take care about. Similarly, if you reduce the current and then if you increase the terminal voltage, then the same power can be exit, but at the same time you can reduce the current. So in that case we can get a safe operating area. And similarly the gearbox or direct drive. So that whether are you going to connect your motor via the gearbox, or else directly you are going to connect to the motor with the wheel. So like that you have to take all the consideration. And and along with that, you can take the cost also. So let us check top 10 best luxury cars in that about 2021. So before that, we will discuss how we can understand the torque with the MATLAB Simulink. So let us move to the MATLAB. Just go to the Simulink, create one blank box. Yeah. Okay. So now let us take a DC motor. So now we will start the DC motor and then we will try to operate at the maximum load. So for that one we need a DC supply. So just to go to library browser, open the library browser and go to Simscape block. So here you can get all the models. So in the electrical segment, go to Sim specialist parameters. So here are fundamental blocks. Just to take machines, take a DC machine, and similarly now we have to configure the motor parameters. So in this DC motors there will be a terminals called A plus, A plus, A minus, F plus, F minus, nothing but armature and then field. See here we have just to choose the preset model. So like 300 voltage first model, 5 HP, 240 voltage, 1750 RPM, and then field voltage is a 300. And that mechanical input we are going to give the torque value as the mechanical input. That is, which means that we are loading the motor with the torque value and field type. So other parameters no need to change anything. So just simply keep default value. And now we have to this is the input terminal for the motor, and again these are the voltage supply terminals, and this is the measurement terminal. So to measure the output of the block, so just take a bus selector and if you open the block, then you can understand the motor parameters, what are all the parameters we can measure with this help. So just we can measure the speed and armature current, field current, then torque. And now we have to take a supply, we have to apply the voltage for the field as well as that armature. So for armature it's a 240 voltage, and then field is a 300 voltage. Just to take a DC voltage supply. So amplitude voltage is about 240. This is for armature, and similarly you can connect field also. Yes. So this is the field voltage is about 300 voltage. And now we have to connect a torque value. So just to take a torque about to apply the torque, just to take a constant block. So one is nothing but 1 Newton meter we are applying. So from this graph we can calculate the value how much load is applied to the motor, and then for that particular load how much current has taken. So just to take a scope block. Yes, just to connect accordingly. And now we have to add the power guide block to run the simulation. So we have connected the motor. So now let us check how the simulation can be run. See here, the 1 Newton meter is almost a negligible load. It's gave some value. Just to change the parameter so that we can see the output in clear manner. So now this is the speed we are getting from the motor. It's like a no load speed, and similarly this is the armature current. Initially it took huge, and after that it settled some value. And similarly there is a field current and then electrical torque. So this is called electromagnetic torque, which is produced by the motor, and again it's this parameter is inside the motor. So now let us load the value. Similarly we can check the output, I mean with the help of a display block also. Just to take a mux block. Just now just run the value. See here, this is the equivalent value. So the motor is drawn like RPM to sorry, this is radian per second. So just to convert RPM value, 30 by pi. 30 by pi. So this is called RPM. So for 1 Newton meter, the motor running at about 2200 RPM. So this is called no load speed. Generally, the no load speed will be higher than that one. So whenever since we are applying the rated voltages, suppose if you apply the gradual voltage or the voltage control method, then the speed can be achieved. So now let us understand from the graph. So since there is no any load, that motor is rotated at this much speed and then drawn this amount of current, that is field current is about 2 ampere, and then armature current is about 1 ampere, and similarly that torque, electromagnetic torque, Newton meter, 2.2 Newton meter. And now if you change the load, how much load can be applied? See, there is a formula called P, that is a T is equal to P naught divided by omega. So this is the total torque available at the low motor shaft. So the P is nothing but P naught is nothing but if you take a HP motor power, so that is 5 HP. So this is the mechanical power. So HP nothing but mechanical power. So now we have to convert to the electrical one. So here just to take a 5 into 746 divided by, and W nothing but 2 pi n divided by 60, that is the 2 pi n divided by 60, that is the 2 pi, and 60 is the constant, n is nothing but the speed. So here let us solve this equation. 2 pi into 1750 divided by 60. So if you solve this equation, you will get a total torque. For total torque which is available, this much torque can be loaded to the motor. So now just open the MATLAB and 5 into 746. So there is a 3730, and similarly 2 pi n, 2 into pi into n 1750 divided by 60. So 183.256. So just 3730 divided by 183.2596. So this is the 20 Newton meter is the maximum torque you can apply for this motor. So here let us apply this value to the motor. So 20 point. So 20.35 we have to apply. So let us take, this is the full load torque, 20.35. So if you apply that value, so let us check what the speed, and then what is the current, total current, and field armature current, field current, everything we can check in detail. See here, if you apply this value, then the motor rotating at 1750, this is the rated RPM, and similarly that armature current is increased, and then field current is still constant, and here again the torque produced by the motor is about 21 Newton meter. See here, this 21 Newton meter is the electromagnetic torque produced by the motor. So now you should understand how much torque can be produced. So that is called maximum torque by the motor. So now the concept is the motor control mechanism, entire motor control mechanism allows you to produce a maximum current. So in that case, that algorithm will taken care to generate that value. So now let us check, let us apply variable speed for the time. Just to take a step step block. So step time, if you run that simulation time about 5 seconds, so initial value 0, the final value let us keep it 5 Newton meter, and 1 till 1, I mean at the time of 1, and similarly just to take initial value 0 and final value will be again just at the 2, final value will be 10. So that is half load, quarter load, half load, and then full load. So like that we are going to add to the motor. But the third second, the 20. Just add these 3 value and connect to the motor, then we can check the responses of the motor. To take some block, connect all the things and connect motor to the port. So before that, just verify the scope, verify with the scope. Whether the signal is properly applying or not. This is simple logic. You can develop your own logic. So that instant is about a 3. So you can run the simulation till 4 seconds. Initially it is 0 load and then quarter load and half of the load, and then finally it's applied full load. Okay, load has been added, so we have to change the value 5, and again we have to add 10. Yes. Yeah. So initially is no load and then a half quarter load and then half of the load, and finally we are applying the full load. So like that, if you apply to the motor, then let us check the responses. Here during the no load speed, during the no load, then the speed is above the rated speed, and similarly the current drawn by the motor is also very less. And again the field current is exactly same because the load armature only going to change it. And again the produced the motor produced torque is about electromagnetic torque. Simultaneously it's keep on change based on the armature current. So now the point is the armature current is directly proportional to the torque. So whenever the electrical torque, that is called electromagnetic torque, which is available inside the motor, so that if this parameter is available enough value, then only you can drive your load. Otherwise you cannot drive a load. So now the point is, if you directly control this torque, then we can control the load. So that is called direct torque drive systems. And again here, see from this graph, one more important observation called see here. So during this torque also you can change the speed, you can change the speed of the vehicle. So in that case you have to implement a control mechanism to drive this load with at a particular speed. So to achieve this value only, to achieve this features only, we are trying to implement the speed control mechanisms. So let us check one by one speed control mechanism for the DC motor, and then induction motor, BLDC motor, PMSM motor, and then SRM motor. So consequently, so keep engaged with this entire series. Definitely this series will give you complete idea about the electric vehicle systems. And so now let us discuss about the top 10 electric cars in this 2020. So this is as of May 2021. This list is published in this Autocar website. So you just visit this all these websites, and then grab all the points, like what is its so what is its data, like what is the maximum value, how much the capacity, and I recommend you just visit go through all the specifications of the cars. Yes, here the specifications, everything will clearly mentioned. What is its range per battery, and how much distance can cover, and the performance, price details, everything will be mentioned. So I recommend you all, so please visit all the vehicles specifications to understand more about the electric vehicle system. And similarly, again there are one more point called the top 10 best electric motorcycles in the world. So these are some top 10 motorcycles. So here also you can get all the points. So just to go through it, grab the points. So from this point, this is the points you are going to search, and then you are going to develop a complete control mechanism for the electric motors. So to implement a control mechanism for the motors, then you should know these points. Then only you can recognize, and then you can understand, you can realize the controlling mechanism. Thank you. I will catch you in the next